Our next speaker is well known. How many of you know Golang Show podcast? Raise your hands. Oh, many of you. Okay. I think many of you knows our speaker as Elena from Golang Show. Today she came from Berlin to talk to us about best practices for cloud native Go services.
Thank you. Doesn't work. But actually, I think I can use my keyboard.
Okay.
So not a big issue. So yeah, 4 years ago, I started writing microservices in Go. And after I wrote a few simple applications, I figured out that it's not enough to know the language itself if you don't know how to apply it. And yeah, it was a big issue to understand what you need to do if you want to prepare your applications for production. Luckily, I was not alone, and with my colleagues, we were able to define requirements for the applications, for services. And some of these requirements were based on general principles, on general cloud-native infrastructures, for example. Other requirements were based on Go-specific things. And this year gave me a wonderful opportunity to work with different teams on different projects and constantly improve this approach. My name is Elena Grahovac. I work for N26 as a lead DevOps automation engineer. And today we will talk about cloud-native applications. With this talk, I want to help beginners to bridge the gap between hello world and the real production-ready application. So let's start from cloud-native definition. Actually, there is not one definition for cloud-native term, and different people understand it differently. But if we talk about cloud-native, we can consider some things that are more or less, that are more or less the same. First of all, when we use cloud-native, we usually think about infrastructure that is managed, and we usually have platform as a service on our infrastructure, like, for example, Kubernetes or... Why does my slides change automatically? I would say automatically. So, yeah, we also probably deal with containers, and all our services are containerized. And we also usually write applications based on microservice approach or something like this. And important thing that communications between different services are provided by network. And also we usually have a lot of DevOps techniques to make our project or to make our process better and more efficient. You might want to ask, what is the difference between DevOps and cloud native in this case? So DevOps is focused on people and on culture. And DevOps defines the way how your team should work, how the members of one team should work together, and what kind of tools and technique they should use. Cloud native, in its turn, focused on the design and development practices. And it's quite obvious that cloud native is not possible without DevOps. But how do you think? Is cloud native can help growing DevOps culture? Do you think it helps or not? Who thinks that it helps? No? I think it helps because, well, in the past, people often used to consider DevOps culture as a set of rules that first of all makes infrastructure people or system administrators or operations people developer friendly. It means that, like, as a developer, I come to my infrastructure engineer and I can ask whatever I want, and if my infrastructure engineer support DevOps culture, they should provide all what I want. Well, it's not true. DevOps is not a one-way road. And actually, cloud-native world encourage developers being more infrastructure-friendly and being more interested in infrastructure. For example, with self-healing and with fault-tolerant applications, developers can take an initiative to work on parts that were historically more infrastructure-based. Okay, let's start from defining requirements. if we talk about cloud-native requirements, we probably can mention 12-factor applications, because 12-factor approach was a nice way and made a very important step to prepare deployable, distributable applications. But if we want to think about cloud-native, we can find that 12-factor is not enough. And there are some other important topics that should be considered when we think about applications that are written for cloud-native infrastructure. So let's talk about it. First of all, of course, you might want to think about structuring. And even if you don't have enough experience with Go, you probably have already tried a few different ways to structure your applications. And yeah, if you were here at previous talk, you already know how to structure your application. If you missed previous talk by cut, I strongly recommend you to find this video and watch it, because it's super practical and super important to know how to structure your application. What are different ways to structure and when you should choose one or another. When I structure new application, I usually consider 3 directories always. First of all is CMD, where you can keep your entry points. And for example, you can prepare different subfolders for your different applications, like one for server, another for CLI tool. And why it's good, you might want to ask. Well, I know only one practical thing, but if you want to try it locally, you can do go get, and then you will automatically have your binaries in the go path/bin directory. It might be very, very useful for your local development. But actually, there are many packages and well-known projects who use the same approach. So now it's like kind of standard to use CMD for your entry points. Second directory I want to mention is internal. And this directory is for packages that should be available only from your project. And for example, if I want some package not being available from some external project, I will put it to internal, and only my project will be able to use it. I didn't know about it. I think, yeah, I learned it a few months ago. But actually, yeah, it's available since Go 1.4, and it's quite an old technique. And the first directory is, well, we probably all know about it. It's vendor. It's a place where we should store our dependencies. But you can see the link here. I will give you the link to the slides later, so you will be able to check out all the links I present here. And yeah, this project is trying to identify a kind of standard for structuring Go applications. I would say that it's probably up to you, up to your team, and up to your project to choose or not to choose different ways and different rules of structuring things, but you definitely should think about it. Because, yeah, as you already know from previous talk, it's very important to structure things and to think about it in advance. OK, let's assume that we know how to structure things, and we already started writing some code. What's next? Probably we need to find a way to understand if our code is written properly or not, if our code is good or not, and yeah, what is in general about code quality. Here we might have a few practices. And first of all, of course, it's testing. It's also static code analyzer and profiling. Let's start from testing. The standard library offers a nice package testing, which you can use without having any external dependencies. And it's a way that Go standard library use for testing standard library packages. And you might see a lot of this kind of like statements. When you call it, like someone or you call a function, and first of all, you need to check it for errors. And if there's no errors, you can check it for equality. And yeah, actually, these four lines are what you always will have in your tests. You might want to ask where are my asserts if you came from another language. And yeah, another approach that worth to be mentioned is the approach when you use testify library that allows you to do assertions. And you might see that this kind of code might look a little bit more beautiful than this one. There are less lines of code, and you don't need to read everything to understand how it works. But well, actually, there is a reason why the Go team decided not to implement this approach as the standard library, and yeah, you can learn about it. Actually, in Go, there are many useful techniques about testing and many different ways to test applications. So this, what I definitely recommend you to learn how to test applications. And what is important, when you start writing tests, you can understand how to structure your applications and also how to define different modules. And for example, how to define interfaces between different modules. And if you don't know how to provide dependencies, unit testing will help you again. So personally, I prefer to start writing tests as soon as it's possible. Maybe sometimes even before I started writing code. OK, so is there any other way to check code before we run it in production? Yes, we can run static code analyzers. And there are three main possibilities. First of all, we can check code against how it looks like for its style. Secondly, we can detect potential bugs, and for example, shadowing. And third, and very important thing, we can scan our packages for security problems. We can know if we're secure enough or not. So I can recommend two tools that becomes more and more popular in the Go community these days. First tool is Golang CI lint. It's a set. It's not a set. It's a runner for linters. It doesn't provide any linters by itself, but it runs 30 different linters from the standard tooling and from the linters provided by community. And it works really fast. So I definitely recommend it for continuous integration or for personal reasons, for personal usage. And if you want even more tools, you can use GoCritic. And the author of GoCritic is here. Iskander, please raise your hand. GoCritic provides more than 60 different linters. And as I understand, the authors are interested in having more and more linters. So if you have any ideas how you might want to check your code, please talk to Iskander. He will be probably happy, I hope, to hear you. OK, so we can check code against different things. The question is when we want to check our code. I would say on every stage, on every step when you start to develop it. First of all, you want to check it on your local machine. And again, it's important to check your code before you commit something and push something, because it's a kind of check, and it's a kind of way how you can help your colleagues understand that your code is good enough. You can add, for example, pre-commit hook that will run linters, that will run tests maybe, or at least linters. Maybe not all linters, but at least important ones. And with it, you will always push code that complies some level of quality. Secondly, of course, it might make sense to have some hooks on the server side, or for example, maybe integrate Git with some continuous integration system that will automatically check every push, every pull request. And again, it will help your team members to spend less time on code review, because some potential bugs and things like code style will be checked automatically. And what's important here? In the case, if you don't want to install tools on the continuous integration machine itself, you probably would like to run these checks in Docker container. It's possible, but please separate your production Docker container when you run binary and the Docker container when you will run tests or third-party tools, because of security reasons. I trust Iskander and I trust his tool, but I don't know what might happen during the check-in phase, and I don't know if somebody can somehow replace this tool with some insecure code that might break my application. So I separate Docker files and run tests and checkers in a separated one. And of course, yeah, continuous integration is the king or the queen, and yeah, please use it and check your code. OK, let's assume that we know that our code is good enough, but how to measure if, for example, how much CPU or memory our applications use in runtime, or how much resources in general it uses, how performant is our code. Luckily, the standard library provides a tool, a special tool, profiler. And to have profiler for your application, you simply need to import netproof library. And in this case, you will enable profile handlers, and you will be able to call your application for debug and see profiles, and for example, understand how much CPU do you use, how your routines work. You can trace something and check what places should be improved. Interesting fact that pproof was actually presented by Google and provided by Google. And if instead of standard library, you try to use GitHub Google pproof, it will give you more features. It will give you more fancy user interface. So feel free to try it. But of course, the developers can't tell you that it's safe enough. So if you want more safety, use standard library. If you want new features, use Google library. So there might be one actually interesting thing. OK, by default, I will have debug URL, debug prefix in my URL. But what if I want to change URLs because of some reason, because I want to manage them somehow? It's possible to provide all the pproof handlers with something like this. As you can see, it's quite a lot of code, but it's quite simple code. We just refer handler functions, what we need. So sometimes people think that it's not possible to redefine paths. Actually, it's possible, and sometimes you just need to go deeper to the library, to the source code to understand how it works. OK. So let's assume that we understand our code quality. What's next? Let's go to something more cloud native. And there are two important topics, observability and operability. And now we need to find the way how our application should deal with infrastructure and how we can, for example, understand what's going during the runtime. Not in terms of performance, but in terms of maybe business logic or some other logic. Probably you should start from logs, because logs help you, first of all, to understand when you had error or strange situation. But it's also important to log different stages of your application. When you start application, first of all, you read configuration, and you can check if configuration was read correctly. You can try to connect to the database, and if you didn't connect, you can log this situation and stop your application. You also can define different log levels to be able to, for example, debug something on your local machine, but to not to have too many lines of logs on the production machine. And sometimes you might want to use special tags to tag different part of application with the same label. But there is, again, one tricky thing. If you need a super fast application, for example, if your service should respond in 10 milliseconds, in this case, some loggers might be quite slow. And in this case, please check if this is a logger who makes your application slow, and choose maybe another logger. An example. For example, one of the most popular loggers is Logrus. And in this case, we use two things. First of all, we use log level. In this case, we use info. And we also use label. In this case, we use animal. So, for example, our logger collector will collect it in some way, some proper way. And we will be able to find all these tags from this application on the logger collector level. OK, what else? Also, you might be interested in metrics and tracers. And metrics might help you to understand if you require CLA requirements, if you work with CLA requirements properly, and also if you work with your business requirements properly. So there are two ways to define metrics. First of all, you need to think about how fast your application should respond, and something like this. Maybe you want to measure latency, for example, and maybe some request and response parameters. And you also might want to measure business metrics, like, for example, how many registrations you have at the moment, or how many sales. Because if you see that, like, for example, before the release, you had 100 registrations in Hour, and after release, you have only 10, probably something is wrong with your application. So metrics is a way to understand how your application works and what happened. Something happened. You also might be interested in tracing because it's a technique that can show you how a single user request went through your application or through a set of applications through your microservices. In this case, it will be a distributed tracing. If you want to start dealing with it, I recommend you to check out OpenCensus project because it provides a nice interface that is vendor agnostic and that can help you to identify these tools on your application. Okay, let's go to operability. Cloud native applications are usually the applications that have a lot of responsibility about themselves. And one of these responsibilities is health. And yeah, the simplest health is like, for example, you might want to provide a handler and your application will respond if it's healthy or unhealthy. Healthy if everything is fine and, for example, you can connect to the database and all the necessary resources are available. But sometimes it's not enough. Sometimes you also might want to understand readiness of application. And you might want to report if application is ready to handle requests. Could you give me an example when application is not ready to handle requests? Yeah? Yeah, when, for example, your application is starting and you need to connect to the database and maybe load some configuration or maybe some other resources, it might take some time. And yeah, in this case, probably it's better to firstly show that your application is not ready to handle connections. And the same story about shutdown. We should use Graceful Shutdown to close our connections properly. And in the case if we already it stops the server, we probably shouldn't allow to send requests to the application. Actually, one of the cloud native practices is designed for failure, and what Go can offer us, or what practices we can find in Go. First of all, we need to recover panics, because, for example, in the case of your application is a server, but it also has some dealing with some jobs, and if one of the jobs panicked, and if your application don't recover panics, all your application will be stopped, and probably without dealing with connections properly. Also, please don't panic by yourself, return errors. It's again about structuring, about identification of your services. And I think that actually only main function can panic. For example, when you use fatal level on the logs, your application will panic. But before, it will write a log. So it will be done more or less properly. Also, yeah, of course, if you return error, someone should handle it. And again, it's a question. What part of service is responsible for error handling? And answers might be different, but this is something that you should decide for yourself. And of course, to be able to close your application properly, please listen to the operation system signals, because, for example, again, your platform might send you or might send to the container a signal, and container will send it to the application, and the application should be stopped. And in this case, again, it will be better to stop the jobs properly, maybe send cancellation context to different services or different jobs that are done by application. Okay, let's go to other techniques, versioning. And sometimes it might be very important to provide some information about the application inside the binary. For example, what is the version, current version, or what was the hash of the commit that was made to prepare this particular binary, or maybe some person signed this binary and you need to keep his signature somewhere. And you can use linker to provide this information. Again, there is a super simple example. Yeah, very small piece of code and a way how you can add set of special, how you can set a special version during the compilation phase. So, okay, next important thing is configuration. And 12-factor recommend us to set configuration via environment parameters. But if you read environment parameters one by one, and if you have quite a lot of these parameters, your source code will probably not be very nice. And there is a system solution that I like very much, envconfig library that was written by Kelsey Hightower. And personally, I always try to use it because it helps to keep your configuration nice, structured, and very well written. You also probably have some secrets that you can provide via environment that you want to provide from some secret storage, like Vault, for example. And in this case, it probably also might make sense to provide a nice solution to deal with Vault. Maybe something similar, like envconfig. You can see how it works and yeah, create something very, very similar. Okay, the next topic is very controversial, dependency management. Okay, just a few lines. First of all, if you want to be safe, use dep, because, well, we know more or less how dep works and what to expect from it and what to not. And also commit push and keep your vendor with your repo, because in the case if Git is not available or somebody hacked some library and replaced it with some very, very bad code, you will be safe. And yeah, it really helps to keep your code as safe as possible. But also, if you're interested in the future, try Go modules, because Go modules provide something a little bit different and very useful to deal with your dependencies. For example, you might want to prepare a proxy, and on the proxy level, you actually might run some checkers like linters for external dependencies, or at least some security checkers, and you might be sure that your dependencies is safe enough. So, okay, our application is done. Now we need to release it, and as we deal with cloud native, you probably need to containerize it. There are two main ways how you can create container. First way is monostage image, which is super simple. You just prepare your binary somewhere on your CI machine or maybe even on your local machine, and you just copy it to the container, and it will work because Go has a very nice way to compile binaries for, like, for example, you work on Windows and you can compile for Linux. Well, it probably will not work with Docker, but yeah, in general, it will work like this. But there are some, again, pros and some cons in this approach. For example, if you have a compiler on the CI machine, you will have the same compiler version for every service and for every image you compile in this case. But, well, on the other hand, you need to have a compiler on the CI machine. Maybe you have multiple different programming languages, and you just can't keep all possible tools for every programming language. In this case, multi-staging builds might help us. So during the first stage, we define how we are going to compile application. We check out Go repo. We, for example, prepare a special user to run our container from root. We also can do what we want. We need to build a binary. OK, we prepared it. And then in the same Docker file, we can use the second stage. And actually, it's the same what I just showed. In this case, we use container from scratch, and we just copied our prepared binary. And this second stage will not have, in production, it will not have any layers that were built on the first stage. So actually, these two slides present two parts of the same Docker file. And again, it helps you to keep your code as safe as it possible. OK, let's see what we can do next. We prepared everything manually. Now probably it might make sense to talk about automation, how to automate the steps that we done. First of all, we probably have some repeatable actions, like, for example, compilation or running tests or running linters. You might want to use different flags or different configurations. And sometimes it's quite, like, it's not very interesting to every time try to remember what kind of flags do I need, what should I provide. So probably we should set all repeatable commands somewhere. And we will use these actions from continuous integration again, or maybe from your local machine, or maybe when we run some checkers and tests. And there are two ways to do it. First way is very universal. It's GNU make. It's a classical approach, and probably your interface people will understand you. But I know that some people think that GNU make is not fancy enough. So there are also some fancier tools, for example, with GoTask, which is written in Go, and it's actually an alternative for make files. But some people prefer it more because, well, for them it seems more, again, look like GoWay thing. So it's, again, up to you. Please choose what you want, and just enjoy it. So, OK, we know how to automate repeatable actions, and now we need to prepare we know how to actually prepare like a typical service. And again, in the case if we write microservices, we can go through the same way many times. And first time, when you need to identify all the requirements, when you need to keep them, when you need to go through them, it's very interesting. Second time, it's like, OK, now I can remember how to do it. When you need to do it third time or fifth time, it's not interesting at all. So there is a way to not to deal with it. And with code generation, for example, we can provide automation of creation of these Hello World services. We can provide a template because we know how we structure our code, we know the parts that our code use, we know what kind of dependencies we might want or might not want to use. And yeah, we can just, based on the details that are specific for our project, we can just provide the typical service and automate creation of such services. And again, there is a link of an example of a service. But what I can see for different projects, these services might be really different. So probably it might make sense to create something for your own needs. And the next talk at this room will be given by Max Chechel, and he will give some insights how to deal with Go code generation. So if you're interested in it, stay here. OK, what we learned? Yeah, we learned different techniques, how to structure our code, how to provide code quality, how to check it, how to profile things, how to set logs, how to handle errors, what is good, what is not very good, what you could try to make your service more observable. Yeah, different topics. So actually, what I want to say, what's next? First of all, discover, try, and adopt new techniques, because cloud native world is a very new world, and it evaluates a lot, and there are more and more new tools and techniques that are discovered by different teams, and maybe you are one of the team who can find something new and very useful. In this case, please share your experience with the community, because this is how the world grows, and this is how people can improve their experience and their job. And if you found something, see you at the next GoWayFest as a speaker. Thank you.
Thank you, Elena. Other questions to Elena?
What do you think about checks that are not errors, but rather suggestions? Like, it could be an error, but it shouldn't be treated like a CI failure.
Could you give me an example?
It's like this code looks suspicious. It might have a mistake in it. For example, copy-paste error, but it could be valid code. So it compiles, it can run, and sometimes it's correct, but there is a possibility that it is a mistake. So the problem is there can be many of such suggestions. So.
Yeah, thank you for the question. Well, I'd say it's again a kind of controversial topic, because sometimes you really can't identify if you have an error here or not. And well, another example is, for example, like when you need to go lint, check for comments, and all your exported structure should be commented. And if you don't comment them properly, it will tell you that you have something wrong. But actually, it's not a big deal. Maybe it's your very internal thing, and it's not a big package, and it's quite obvious, so you don't need to mark it as not working. I think it's, again, up to the team. The team should understand what we want to consider as error, what we should listen to, what we shouldn't. Like, for example, possible security problem is when you call external commands from your service. And JAS will mark this code as a possible security problem. But if you know that the application that you run is secure enough, is safe enough, you probably can run it. So it's kind of like, again, up to the team. Do you want to have extra checkers or not?
Interesting thing about optimistic merging is that is avoid this problem. It's like you can merge, and then you can fix those problems if you really want to. They're optional, but the person who sent the patch, he sees these issues.
But yeah, well, you can mark it, like for example, again, linters can mark it with some specific comments to ignore it, to be able to merge it. But you can add, like again, some comments to check it later or fix it later. Or even better, instead of writing to do in your code, just create a new issue in your issue tracker to not to forget about it and plan it. Like for example, okay, next week we will have some bug fixing session, and during that session we can go back and check if it's an error or not, or if we should fix it or not.
Okay, guys, more questions?
Hi, Lena. Thank you for your speech. I just wanted to add a few lines to the linters problem. Like on large code bases, you just can't force your team to fix all the errors that linters give, because it can be 100 thousands working hours to fix all these errors. But there is a nice approach to fix something that you make worse. So like they see the links only on the lines that you change in this commit. So like hopefully over time you can get like cleaner code base, and this is one approach. And I also wanted to ask, what do you do with sensitive data in the logs? Do you have like some approach, like general approach for that?
We don't store sensitive data in logs. Maybe it's like our company-specific thing because we are a bank and we have quite a lot of requirements. And for example, we don't store any kind of sensitive data. We can store maybe request ID, but not sensitive data.
But how can you be sure that there is no sensitive data in request?
Because of code review, during the code review phase, developers check each other, check what other developer don't put any sensitive data. Well, maybe there is a way to write a linter that can check if you put sensitive data to logs or not somehow. I think theoretically it's possible.
Okay, thank you.
And by the way, thank you for referring this problem because in the case if we started a new project and we started dealing with linters, we always have a clean code, everything is nice, but if you deal with an old code base and we run linter and we see a huge amount of errors and we don't know how to check them, it might be an issue, yeah.
Okay, so let's thank Elena once again.